right, so today we're going to take a look at section 2.1. Okay, we'll spend 3 days on it. We'll do part 1 today, part 2 tomorrow, and part 3 on Thursday. So the first thing we're going to look at is angles. Okay, what an angle is, how we measure it, and then also how we can convert between the two different ways we can measure it. Does anybody know one type of unit that you can use to measure an angle? Degree, yep, so you can use degrees. And there's another unit, which we're going to look at today. All right, so before we talk about an angle, we're going to talk about what makes up an angle. And an angle is made up of two rays that have basically what we call a common starting point. That's a vertex. So this is what a ray looks like. It's just a single ray. That's not an angle, just a ray. Extends in one direction forever. But then when you put another ray with the same vertex, same starting point, now you've created an angle. Okay, so when we draw an angle by itself, that's what it looks like. It's two rays. Sorry. Okay, so we put two rays together with a common vertex. Now we have an angle. Now that's the way I drew this angle up here. That's not a great way to draw an angle. Okay, there's a certain way that we want the angle rotated. That's kind of like it's been turned. We don't want to draw it that way. So we'll talk about a way that we can draw an angle so that everybody's looks similar. Okay, so like if I say sketch a 90-degree angle, I don't want some people to draw it like that. That would be the correct way. Or this is a 90-degree angle, but it's not the standard way you draw a 90-degree angle. This is. Right, so we'll look at how we can do that so everybody's kind of looks similar. When you draw an angle, it's made up of two sides. There's one side, and there's the second side. Each of those sides has a name. This side is called the initial side, and then the other one is called the terminal side. And the way that you figure out which side is which is if you're standing between the two sides and you rotate counterclockwise. Whatever side you start at, that's the initial. And the side that you would end at is the terminal. So if I drew something like this, which side would be the initial side there?
The almost vertical one?
Yeah, the one that's pointing more up. Because imagine you're between the two rays and you rotate counterclockwise. Where you start is the initial, and where you end is the terminal. Okay, and here's another picture of the same thing. Out of the three that I just drew, this one is the best way to draw one because it's in what we call standard position. Okay. The other two are not, but this one is. Now, I haven't really explained to you what it means to draw an angle in standard position, but by looking at the two that I did up above and the one that I just said is in standard position, did anybody have a guess when you draw an angle, what you have to do to make it in standard position? There's two things, you'd only be able to tell one of them from this picture. Yeah?
The initial side is flat.
Yeah, the initial side has to be horizontal, yeah, and it has to point to the right. Okay, that's one of the two things. The second thing I'll tell you because you couldn't see it from this picture. Now, we also talk about angles that are inside of shapes. So if you had something like this, there's still angles there. But these three things that I just drew are not rays. What are these three things?
Those are just line segments.
They're line segments. So even though we wrote down the definition of an angle is when you have two rays at a common vertex, you can have two line segments with a common starting point, okay, if you're talking about a shape. Right? So when we talk about a polygon, generally an angle has two line segments. When we talk about an angle all by itself, it has two rays. Now, when we measure an angle, like what's the device you could use? Anyone know the name of it?
Protractor.
Protractor, yeah. You could use a protractor to measure an angle. And when you measure an angle, it's measuring an amount of rotation. Okay, that's basically what it is. How much did you rotate between the initial and the terminal? Well, there's two directions that you can rotate. Right? If you think about like on a circle, what are the two directions?
Clockwise and counterclockwise.
Right, clockwise and counterclockwise. Right, so this is it's a program that lets me draw different angles. All I can do is move the terminal side. The initial side will always stay right there. As I rotate around the circle in a counterclockwise direction, I get angles that are positive. Right? The bottom number we're going to talk about later on, but the top number, that is degrees, okay, 133 degrees. What do you think is going to happen if I rotate instead of counterclockwise and I start going clockwise?
It'll just get smaller from 360.
Okay, it'll get smaller, but what's going to happen?
Once you get to like the initial line, it'll go from 360.
So what's going to happen if I keep going past zero, you think?
Start at 360.
Start at 360?
Yeah.
Okay, so you might think it starts at 360 because when you get right here, you're at like 359. So if I keep going, it would go to 359. Anyone have another guess what's going to happen? Well, if you watch the number, and the number keeps continuing in the pattern that it is right now, what could happen to that number?
Negative.
It could go negative, and it does. Okay, so if we keep going past zero in a clockwise direction, we start getting negative angles. So the difference between a positive angle and a negative angle, when you're talking about rotation, is just direction. And when we're talking about a shape, there's no such thing as a negative angle in a shape. Like a triangle, there's no negative angles in a triangle because there's no idea of direction in a triangle. Right? But on a circle, degrees can describe direction of rotation. So that's why it could be negative. All right, so let's write that down. So if the rotation is in a counterclockwise direction, that's positive. If the rotation is in a clockwise direction, then it is negative. Okay, so two different directions of rotation. Now, if we had a choice, what kind of angles do you think we would prefer to work with? Positive, yes. We definitely prefer to work with positive angles. Let's see. Let's take a look at what it means to draw an angle in standard position. So I kind of figured out one of the things, and that's that the initial side has to be horizontal. Okay, the initial side has to be on the positive x-axis, and the x-axis is horizontal. So that's part of it. The other thing is when you draw the angle, the vertex of the angle has to be at the origin. So those are the two conditions if you have an XY axis to draw something in standard position. So if I did this, is that angle in standard position?
Well,
No?
it's not.
Why not?
It's not
The vertex is not at the origin. Okay, so that's not standard position. How about if I did something like this?
No.
Is that standard position?
No.
No. The vertex is at the origin now, so that's good. But what's wrong with it?
The initial side is on the x-axis.
Right, the initial side is not on the right side of the x-axis. Okay. The terminal side is on the y-axis, but the terminal side has nothing to do with the definition of standard position. You can put the terminal side anywhere you want. Okay, so that is standard position. So any questions on what it means for an angle to be drawn in standard position? All right, so I'm going to go back to that program. So we'll bring that back up. And I want to look at a couple different angles. And I want to kind of point something out. So let's look at 90. Don't worry about any number at the bottom, just the top number. Okay. So that's a 90-degree angle that I just drew. Initial side is horizontal. Terminal side is vertical. And I just want you to look at where the initial and terminal sides are. Now, let me draw this one. 450. And I want you to look at where the initial and terminal sides are now. How do the initial and terminal sides, where they are now, compare to where they were for 90? They're the same. Right? The initial and the terminal sides for 450 degrees are exactly the same as 90. Right? How about now? Same thing again. The initial and the terminal sides are in exactly the same spot. What am I doing? Think like arithmetic-wise. I mean, I know I'm going around one time, but I had 90, I had 450, and I had 810. Those three all look exactly the same if you ignore the red spiral. That's just showing you how many times you went around. But what are you doing each time you go around? Yeah?
Adding 360.
Right. You're adding 360. And if I go around the other way, to get from 810 to 450, or to get from 450 to 90, or to get from 90 to negative 270, I'm subtracting 360. Right? So when you add or subtract 360 to an angle, it does something special to it, and it finds an angle that we say is coterminal. Okay, so let's pick one of the angles that we just did. Let's pick 90. I'm going to use a trig function. Okay, we don't even know what the trig functions are, or we haven't learned them yet in this class. You don't really need to. I just want you to see a pattern. I'm going to type in the sine of 90, but I want to be in degrees. And we'll talk more about how to change the mode of the calculator. You don't need that right now. When I type in the sine of 90, I get 1. What do you get if you add 360 to 90? How much?
450.
450. Let me take the sine of 450. How does that compare to the sine of 90?
Same.
They're the same. Right? Let's try a different trig function. Let's try one called cosine. Cosine of 90. 0. Okay. Let's try cosine of 450. 0. It doesn't matter what trig function I use. If I have an angle and I add or subtract 360 to it, all of these answers will always come out the same. So let's do like 810. That was the next one if we added 360 again. What do you think the sine of 810 is going to be?
1.
It's going to be 1. And the reason it comes out the same is because the initial side and the terminal side line up exactly in all those different angles I just showed you. So the point of that is if you have a really big angle, like 1600 degrees, and you have to figure something out with it, that's going to be hard to work with because it's so big. So you can make the angle smaller and it won't change the answer. Right? If I subtract 360 and I keep doing it a bunch of times, eventually I get an, 1240 minus 360 minus 360. Now I should be able to just keep doing it. Eventually I get an angle that's small enough that I can kind of visualize in my head. Right? 160 is something I can think about. I know 180 is straight line. So 160 is like right over here somewhere. About like that maybe. Right there. But 1600 was too big. So that idea that we can add and subtract 360 to an angle and it won't affect the answer when we press these buttons, sine, cosine, and tangent, that's important. Okay? So what that allows us to do is avoid working with angles that are too big. And if you had an angle like negative 900, that's too small. Right? It's going to be hard to work with it. So what do you think I can add to this number that'll give me an easier angle, but it won't change the answer? Yeah, I can add 360 as many times as I want until I finally get a number that's easier for me to think about. Yeah, just keep adding. Oops, I didn't hit plus 360. Negative 180 plus 360. Oh, you get it. So you can just keep adding 360 as many times as you need to. Okay, so we're gonna, throughout the year, we'll do that a lot when we have an angle that's too big or too small. We'll add or subtract 360 to make it more manageable. And that doesn't affect the answer. I'm not saying that like 90 and 450 are the same number. No, they're different numbers. But when you do trig with those numbers, you get the same answer. All right, so there's two different numbers in this box. The top one is degrees. The bottom one is something different. Does anybody know what the bottom one is? It's still measuring the size of this angle, but it's measuring it in a different unit. Okay, well, the other unit that it's using is a unit that is on the calculator, and it is radians. Okay, so radians is something that we are going to use quite a bit. It's just a different way to measure an angle than degrees. So let's take a look at what are radians. Well, if you look at the word radian, does it kind of look like any other word? It kind of looks like radius, right? And a radius is part of what shape? A circle, right? It's part of a circle. So when I start to describe to you what radians are, I'm going to draw a diagram with a circle. And there's a certain number that comes up a lot when we deal with circles. Circles or spheres or cylinders, anything like that. There's a number we use a lot. What number? Yeah, pi. Right? Pi comes up quite a bit. So pi is going to be a big part of working with radians. And you might have noticed that if you got this angle just right, all of a sudden the number down here changed to something with a pi. And in a little bit, you're going to know how to figure that out. A lot of them don't have a pi. Okay? If you just pick a random angle like 79, 79 is not anything special. They write it with a decimal. But you'll notice any number that's a multiple of 30 or 45, they're going to write it with a pi. And the reason for that is because 30s and 45s are very common in trig. They come up a lot. So our goal is to figure out that question mark. We know in one revolution there's 360 degrees. I think we knew that before today. But the question is how many radians are in one revolution? And what's that? It is 2 pi. Yep. And we're gonna figure that out. How did you know that, Bernie?
Well, if 90 is pi divided by 2, that would mean 180 is pi.
Mhm.
And
pi. Yeah, very good. So yeah, it is 2 pi. So we're going to figure that out. And then the reason we want to know that is because if you have a connection between two things, like degrees and radians, it's kind of like having a connection between feet and inches. Right? So let's say you want to explain to somebody how to convert between feet and inches. Well, you've got to tell them something that's true. Right? It can be anything, but it just has to be a true statement about feet and inches. Can somebody give me any fact that connects feet and inches?
12 inches in the foot.
Yeah, that's probably the simplest one. 12 inches equals 1 foot. Now, with that information, I can figure out anything you want me to figure out to convert inches to feet or feet to inches. Okay, I could think of it as a proportion. On one side of the proportion, I have to fill in something I know that's true. This isn't the only thing that's true, but that's a good one. 12 inches is 1 foot. Now, let's say you want to know how many inches in 13 feet. Just put a 13 there. Now you solve for the question mark by cross multiplying. Right. But the only reason this is going to work is because you knew that. If you didn't know that, then you're stuck. Okay, so you've got to have a connection between the two units you're trying to convert between. Any connection. So that's what we're going to figure out here. We're going to get a connection between degrees and radians. Any connection. Doesn't matter. It just has to be something that's true. All right, so before we figure out what that connection is, I'm going to draw a picture of what a radian looks like. Okay? This isn't really going to help you convert between degrees and radians. It's going to give you something you could visualize in your head to imagine the size of a radian. Because I'm guessing if you haven't used radians before, you probably don't really have a good concept of how to visualize what they look like. Right? Like if I say 90 degrees, most people think of like, a capital L. Looks like a 90-degree angle. Okay? That's what I'm trying to give you here, something you can visualize for what a radian looks like. All right, so what I've drawn is a circle. And inside that circle, I've put an angle, and the vertex of the angle is supposed to be right at the center. I've labeled each ray of that angle as R. What does the R stand for there?
Radius.
It stands for the radius. It's the distance from the center to the edge of the circle. And any line drawn from the center to the edge of the circle, all those lines are exactly the same. So it doesn't matter where you put it. They're all the same. Okay, but I'm focusing on that angle right there. If you measured the length of this arc, right? So if you took like a piece of string, put it on top of that arc, and you measured it, and then you took a ruler and you measured the radius. If the length of this arc and the length of that radius came out exactly the same, then you would have a picture of one radian. And that's a pretty accurate picture, I think. The length of that arc in red and the length of that ray in black, they look like they're about the same, and that would be 1 radian from here to here. 1 radian is about 57 degrees. It's not exact. So that's something you can kind of visualize in your head. If you make the length of this arc bigger than the radius, so let's say you drew it like this. Now if you made this arc in red is a lot bigger than that radius right there. You don't have a picture of 1 radian anymore. You've got a picture of something that's a lot bigger than 1 radian. Okay. Same thing if you make this angle smaller. Let's say those were the two sides of your angle. Now your arc is extremely small. It's definitely not as long as that radius. That means this angle is smaller than 1 radian. So any question on what 1 radian looks like as a picture? All right, so it's good to know what it looks like, but we need to be able to convert it from radians to degrees. In order to do that, we've got to start with something. Okay, so I've got to give you a fact that you can use that will help you to convert between radians and degrees. Okay, so I'm going to give you a fact, very simple fact, and it just says an angle's measurement in radians. So basically, if you measure an angle in radians, it will come out the same. It will come out equal to the length of the arc, but only on a special kind of circle. Bless you. And that special circle is a unit circle. A unit circle is just a circle that has a certain size to it. Anybody have a guess what size the radius is on a unit circle? What is it? 1. That's all it is. Yeah. Okay. And that statement, even though it's a short statement, it's a pretty simple statement. It can be kind of hard to understand what's happening there. So I'm going to show you another diagram that'll explain this. All right, so let's take a look at a diagram that explains that statement we just wrote down. If you measure an angle in radians on a unit circle, the size of the angle will be equal to the size of the arc. So first, we just said we're talking about a unit circle. What does that mean the radius is? If we're dealing with a unit circle? 1. So on this program, I can make this circle any size I want, but to demonstrate what I'm trying to, I need it to be a 1. This program is going to give you 2 different numbers. Let me make it not 1 for a second. This number down here is the size of this angle in radians. This number over here is how big this arc is, like if you put a piece of string on it and measured it. Okay? So they're 2 different numbers, but I want you to focus on this number all the way on the right and this number 2.45. This circle doesn't have a radius of 1. So if I measure the size of this arc, which in this case is about 2.93, and I measure the size of this angle, they're not the same. But let me make this a radius of 1. I just drew an angle in this circle of 2.58 radians. How big does it say the length of the arc is? Okay.
2.58.
2.58. Let me draw another angle. I just drew an angle in this circle now. This is 1 1/4 radians. That's the measure of the angle from the initial side to the terminal side. How big does it say this arc is in blue? Yeah. It says that the length of the arc is also 1.25. So whenever you have a circle with a radius of 1 and you draw an angle inside the circle, the size of the angle between the initial and the terminal side will always be the same length as that blue arc. Okay. But it only works on radius 1. If you change the radius, you can see the 2 numbers now are definitely not the same anymore. Okay. But on a circle of radius 1, it works. Because it works on a circle of radius 1, that's going to help us figure out how many radians in a circle. We don't know a lot about radians right now. At least I haven't explained to you a lot. But we don't have to figure out how many radians to go all the way around the circle. We can figure out another number, and that number will be exactly the same as the number we want. Okay. So let's think about this number, 3.95 up in the green box. That number is measuring the length of the arc. Okay. How much of the circle, if I draw it about like that, how much of the circle does the arc take up? about a quarter of it, right? How about if I draw it like that? How much of the circle does the arc take up now? Half. If I put this all the way around, it would be an arc that's so big, we don't even call it an arc anymore. What do you call an arc that goes all the way around the circle?
Circle.
The what?
A circle.
The shape is a circle, but something about the shape. It's the what of the circle? The circumference, yes. So if we can find the circumference of the circle, which is this number, it's going to be exactly the same as this number. And that's what we want to figure out. How big is the angle that goes all the way around the circle? Well, you don't have to figure out how big the angle is. Just figure out the circumference of the circle. And that number is exactly the same. So that's what we're going to figure out. Now, this just requires us to know how to figure out the circumference of the circle. Does anybody remember the formula for the circumference of a circle? I wasn't planning on figuring out that formula, proving that to you. So we need to know that somehow. Yep.
Isn't it pi times diameter?
Yep, it's pi times diameter, or you could also think of it as the radius doubled times pi, because the radius doubled is the diameter. Yep. Okay, so that's the formula to find the circumference of a circle. What's the radius of the circle that we're working with? We're not working with just any circle. We're working with a very specific one right now. 1. 2 pi times 1. So the circumference of the circle that we're working with is 2 pi. And why do we care about the circumference? Because the circumference, that number, is exactly the same as that number. And that's the number we really want. So if you go all the way around a circle, you can't quite go all the way, otherwise it starts over. But if you go all the way around a circle, think of what 2 pi is. 3.14 doubled is 6.28. I just can't quite go all the way. And that's equal to 360 degrees. So there are 6.28 or 2 pi radians if you go all the way around the circle one time. Oops, you gotta get it right there. So 360 degrees is exactly the same as 2 pi radians. Now we can fill in that question mark. Now we've got a connection between degrees and radians, just like we had a connection between feet and inches. Right? Yeah, it's a very specific connection. It says 360 equals 2 pi, but that's fine. It's just like 1 foot equals 12 inches. You could say 2 feet equals 24 inches. You can use any fact you want, as long as it's true. And that's true. 360 degrees equals 2 pi radians. Okay, so let's write that down. So we know 360 degrees equals 2 pi radians. But what could we divide each side by to simplify that a little bit?
180.
I'm thinking of just a number. So yeah, you're right. And what did you divide each side by to do that? 2, yeah. So if 360 equals 2 pi, then 180 equals 1 pi. That's a little simpler. But usually when you tell someone a connection between two things, there's a certain number in the connection. Like, if you were going to explain to me like how many seconds in a minute, how would you give me a connection between seconds and minutes?
You need a 1.
Yeah, you'd probably give it to me with a 1. You'd say in 1 minute there's 60 seconds. You could tell me in 3 minutes there's 180, but you're making it more complicated for me to think about. Just in 1 minute there's 60 seconds. Okay, so usually you have a 1. I want to get a 1 in this formula. Let's get a 1 on this side. And then we'll get a 1 on the other side after. If I wanted to turn 180 into 1, what could I divide each side by?
180.
Yeah, I could divide each side by 180. And what that does is it gives me a formula that says 1 degree equals pi over 180 radians. So now I've got a formula for 1 degree. Let's say I needed a formula for 2 degrees. What could I do to each side of this equation?
You can multiply the 2.
I could multiply each side by a 2 and a 2. Now you got a formula for 2 degrees. What if you needed a formula for 6 degrees?
Multiply by 6.
You can multiply by 6. What you're multiplying by isn't important. Okay? You can put whatever you want in the purple box. That's what you're trying to convert. This is the part that's important. Whatever you're trying to convert from degrees to radians, you have to multiply by pi, and you have to divide it by 180. But you can put any number you want in that box, 6, 12, negative 8. You've got to multiply by pi and divide by 180. Those are the 2 steps to convert from a degree to a radian. Multiply by pi, divide by 180. So it's always pi on the top, 180 on the bottom, when you're going from degrees to radians. Now we're going to look at radians to degrees, okay, the other way. So let's go back to the fact that we had right here, 180 degrees equals pi radians. And let's get a 1 on the other side. What would you divide each side by? To get a 1 on the right. Yep, divide by pi. Pi divided by pi cancels out and becomes 1. Now you've got a formula that says 1 radian equals 180 over pi degrees. So now I told you 1 radian was about 57 degrees. Well, you could figure it out exactly if you want to know. 180 divided by pi is about 57.3 degrees. So that's a formula for 1 radian. What if I needed a formula to convert 2 radians?
Multiply by 2.
I would just multiply this side by 2 and multiply this side by 2. Now you have a calculation you could do out, and that's for 2 radians. What if I needed to convert 10 radians?
Multiply by 10.
Yeah, just take your equation, multiply by 10, multiply by 10. What you're multiplying by, that's not the important part. This is the important part. Whatever you're trying to convert from radians to degrees, you have to take the number and multiply it by 180 and divide it by pi. Those are the 2 steps to convert from radians to degrees. Multiply by 180, divide by pi. So the 2 conversions are pretty similar. One you multiply by pi, the other one you divide by pi. So they're very easy to mix up. But I can kind of give you a way to make all this automatic. So we won't mix up. Is it divide by pi? Is it multiply by pi? Which way is it? The only thing you have to remember is when I say radians, I want you to think of pi. I always want you to think of pi as being attached to radians. So radians, think pi. When you see a degree symbol, think 180. So just remember those 2 things. Degree symbol, think 180. Radian, think pi. And all of that becomes automatic. Okay, so let's try some conversions between degrees and radians. Okay, so 60 degrees. Right now, the 60 is not a fraction. What number can you always put and make something a fraction? Yeah, you can always put a 1. After a while, you might not need to put the 1 there, but mentally it might help at first. We're trying to convert from degrees to radians. So when we're done, we want this degree symbol to be gone. Where is the degree symbol in the fraction right now? It's in the top. We want to multiply by something that's going to make this degree symbol go away, because we want to end up with radians. Where would the degree symbol have to go in the fraction on the right if it's going to cancel out the degree symbol in the top? It would have to go in the bottom. So the degree symbol has to go in the bottom, which means radian has to go in the top. Now your degree symbol just canceled out. We just have to remember which number goes with radians and which number goes with degrees. What number did I say to always think of when you're converting and you put it next to radians? You put the pi there. And what's the number that I said always goes with the degree symbol when you convert? 180. And now we just reduce what we can, and we multiply. Okay, no common denominators because you're not adding or subtracting. 60 and 180 reduces. What are they both divisible by?
3.
Yep.
Well, 60.
60, yeah, we might as well go with the biggest one. How many times does 60 go into 60? 1. And how many times does 60 go into 180? 3. So multiply what you have left. 1 times pi over 1 times 3. That's your answer. Pi over 3. Let me show you it on here. Let's do the same thing. 60 degrees. Pi over 3. Notice there's something missing. They didn't write RAD after the pi over 3. You're never going to see radians labeled as RAD. I did it here to kind of help you so you could visualize the unit. But we've got to get used to not writing RAD. So in trig, whenever you write an angle, if it doesn't have a label, it's automatically radians. The only time it's degrees is if you put the circle on it. Any question? So we're gonna stop writing RAD now. All right, let's try this one. 150 degrees. So again, if you want to make it a fraction, you can. Think about where degrees is going to go to cancel out the degree symbol you already have. And the degree symbol would go where? Yep, go in the bottom. Radians is in the top, but again, if you want to write it, you can. Like on a test or something, you're not going to see me write it. So radians is in the top. What number do we always put with degrees? 180. 180. And what number do we always put with radians when we're doing the conversions? Pi. Okay, and now usually you end up being able to reduce. What's 150 and 180 both divisible by? 30. 30 goes into 150. How many? 5 times. And 30 goes into 180. 6. So what would you be left with when you multiply straight across? 5 pi divided by 6. And no, you don't do that up. The only time you give a decimal is if they ask for it. Okay? They just say convert to radians. Leave it as an exact answer. And we can check it just if you want to see it. 150. There you go. 5 pi over 6. So that's where these numbers are coming from. Any question on that one? Okay, we'll do one in a couple minutes where you actually round it off and use the pi button on your calculator. I think we do one. If not, I'll just make one up. Yeah, we'll do one in a minute. Let's try -45. I don't normally write the 1 under it. I know there's a 1 there. If you want to, you can, but it's negative 45 over 1. Okay. Same directions, convert to radians. That means this degree symbol needs to disappear. Madison, where does the degree symbol go to make sure we cancel it out? At the bottom. And the number that we always put with the degree symbol in the conversion? 180. If the 180 is in the bottom, that means the number in the top is pi. It's always a pi and a 180. It's just a matter of which one's in the top and which one's in the bottom. Okay, negative doesn't change anything. Just means when we're done, the final answer is going to have a negative in front of it. 45 and 180. Yep, they are divisible by 15, even bigger. 45. Yep. 45 goes into itself once. And how many times does 45 go into 180? 4. And what are you left with here? Negative. You don't have to write the 1, but yeah, negative pi over 4. And remember what the negative means. If you're talking about direction, it means you went which way? Clockwise. Like this. Negative pi over 4. Sometimes because of rounding, the numbers look a little funny the way the computer's rounding them, but it's like if I go to negative 46, it also says negative pi over 4. That's not right. It just must be rounding it funny. All right, let's try this one. Let's do 107. Now, 107, that's not a special angle. Multiples of 30 and 45 we generally consider special. So all the ones that I did so far had pi in them. When you do an angle that's not a multiple of a 30 or a 45, they usually tell you to round. On the test, there will always be directions telling you to round or not round. All right. Anyone tell me what I'm going to multiply and divide by to convert that to radians? Multiply by pi, yep. Divide by 180 degrees. Now, when we do that, even if 107 and 180 had something in common I could reduce, I wouldn't care about reducing it this time because of that. Okay, I'm going to round it. So I'm going to type it in exactly the way I see it. Okay, don't use 3.14. We want to use the pi button. The pi button is second, and then it's right below clear on my calculator. Why do you think I want to use the pi button instead of 3.14? Yep. We'll look at what happens in a little bit if you don't use it. Okay. And it says round to 2 decimal places, so what is the correct answer properly rounded? 1.87. Do I need to put a label of RAD on it? No. None of the problems you see in the homework, none of them on the test are going to have RAD. There's no label, and you're talking about an angle, which we are. It's automatically radians. Okay, so any questions on converting radians to radians? We'll go the other way. We'll do 2 degrees. Okay, I'm going to get rid of these because, well, I'll leave it for the first one just so you can see it one more time, and then we'll stop writing it. Okay, so we've got pi over 6 radians. The directions say to convert 2 degrees. So we want radians to disappear. Where is radians going to go in the fraction on the right? Right. It has to go in the bottom if we want to cancel it out. That means what unit is in the top? Degrees. And the number we always put with degrees? And the number we put with radians? Pi. Okay, so radians is going to cancel. And from now on, that'll be invisible, so we won't have to draw that. But what else cancels? Well, we can reduce, yes, but there is something else that cancels completely. Yeah, the pi. And now we can reduce what you said. 6 goes into itself once. And how many times does 6 go into 180? Yeah, just think of 6 into 18 and add a 0. 30. Yeah. So what do we get for a final answer?
30 degrees.
30 degrees. Do I need a degree symbol on it?
Yes.
Yes. If I leave my answer like that, that's 30 radians. Right? It's like writing an answer as 30 miles when you meant 30 inches. A little bit of a difference. So make sure you put the degree symbol. In pair assessment, the way you do it is you just click in the box and there's a button that comes up automatically and you just click that and it puts the degree symbol in for you. Does it as kind of like an exponent. Right. Let's try 3 pi over 2. Remember, RAD is written right next to pi. Now it's invisible. Okay. What's going to go in the bottom? Pi. And what's next to pi, but we're not going to write it? Radians. So radians is going to cancel. And what goes in the top?
180 degrees.
Degrees. You do have to put that symbol. Okay, 180 degrees. So radians is gone. Pi is gone. And if we reduce, what goes into 2 and 180? 2. 2 goes into 2 once. Goes into 180 how many? 90. And what are you left with for final answer? 270 degrees. Make sure you put the symbol. Okay, any question on that? Let's do this one. 3 radians. When you see a number like that, you know it's radians because if you read the directions, it says convert from radians. So you know what they're giving you is radians, and the goal is degrees. Okay. So when we convert, what's going to go in the top to change this from a radian to a degree? Yep, 180 degrees goes in the top, and what goes in the bottom? Pi. And radians we cancel out. This time, there's no pi next to the 3, so the pi doesn't cancel. Pi doesn't have to be in every number. That's a radian. That's like saying when you measure something, a 5 has to be in every number. No, something might not have a 5 in it. It just doesn't have a 5. Right? This doesn't have a pi. It's just 3. Okay, so we're going to convert it, and we just put round to 2 decimal places. Okay, I'll do it the correct way using the pi button, and then I'll do it the way I said not to with 3.14. So 3 times 180 gives you 540. Divide by pi. So what is that if we properly round it? 171.89. Yep. Okay, you shouldn't have 0.88, you shouldn't have 0.87, you shouldn't have 0.90, it should be 0.89. Everyone, pi is the same for everybody, so that's exactly what you should be getting. Now, if you do it with 3.14, 3 times 180, and divide by 3.14, you get an answer that's off quite a bit. Okay, if I'm looking for 89 as the decimal and you put 97, 89 is not 97, so you got to make sure we just use the pi button and not 3.14.
That'll round up to 0.98, right?
If you round, which this is not correct, but if you did round this number, that's 171.997.
Yeah, but doesn't the 5 round up and then it makes it the 4, 5 rounds up makes it?
Oh, you don't round twice.
Oh, okay.
Yeah, you don't. It's not like you round this number, which could round that, which could round that. You pick one number and you round.
Okay.
Yeah. So if you were rounding this to 2 decimal places, it's 0.97. 3 decimal places, 0.975.
Okay.
4 decimal places, 0.9745.
Okay.
Yeah. Yep. Okay, so don't do that. Okay, any questions on that? All right, so that's converting between radians and degrees. So homework tonight, we're almost 100 pages where we were from last night because we did page 7. So now we're in chapter 2. So it's page 99. And it's 36 to 68 even. Okay, it's converting between radians and degrees. Some they say leave exact, some they say change to decimals.